Hi friends, in last video we discussed the type of number system concept. In this video we are going to discuss about the number system conversion among the four kinds of number system. So if you are familiar with these five kinds of model, you can perform any number conversions, that is now decimal to any other number to decimal, octal to binary and vice versa, then hexadecimal to binary and vice versa. The last one is octal to hexadecimal and vice versa. So let us see one by one. The first model is decimal to any other number system. So in order to convert the decimal number into any other number, we have to perform the successive division with respect to radix of the particular number. For example, if we need to convert the decimal value into binary, we have to divide with respect to 2. And for the octal, we have to divide with respect to 8. And we need to convert decimal into hexadecimal means we have to divide with respect to 16. So let us see the problem. The first model is decimal to binary. So how we are going to convert the decimal value into binary? So the problem is 348. The radix value of decimal is 10. So what is the value for the binary? So 348 we have to divide with respect to 2. We are getting 174 with the remainder of 0. Again we are divide by 2. We are getting 87 with the remainder of 0. Again divide by 2. 43 with the remainder of 1. Again divide by 2. 21 with the remainder of 1. Again divide by 2. 10 with the remainder of 1. Again divide by 2, we are getting 5 with the remainder of 0. Again divide by 2, we are getting 2 with the remainder of 1. And divide by 2, last we are getting 1 with the remainder of 0. For the result, we take the remainder value from bottom to top. That is 1, 0, 1, 0, 1, 1, 1, 0, 0 is the binary value for this decimal number 348. So this will be the result. If suppose they are given in terms of whole number, we have to perform the successive division. So the next problem, in this problem is given in terms of floating point, that is 6.25. Here the 6 is a whole part, 0.25 is a fractional point. For the 6, we have to perform successive division. So divide by 2, we are getting 3 with the remainder of 0. Again divide by 2. We are getting 1 with the remainder of 1. So here also we are taken the value from bottom to top. So 110 is the result for this whole number 6. And for the floating point, we have to multiply with respect to 2, that is 0.25 multiply with the 2, we are getting 0.50. This 0 can be taken outside. So we are getting 0.50 again which will be multiplied with respect to 2, we are getting 1.00. This 1 can be taken outside. So the last one is 0.00. So for the floating point, you can take the result from top to bottom, that is 0.01. So you consolidate whole and fractional part, that is 110.01. So this will be the result for this particular decimal number. So the next conversion is decimal to octal conversion. So for the decimal number, the radix value is 10 and for the octal, the radix value is 8. So in order to convert decimal to octal number, we have to perform the division with respect to 8. So 394 is divided by 8. We are getting 49 with the remainder of 2. Again we are divided by 8. We are getting 6 with the remainder of 1. So here also we take the result from bottom to top, that is 612 is the equivalent octal number for this particular decimal number. This will be the whole part, so we can perform the successive division. So the next problem is given in terms of floating point, that is 275.4. So here also the whole part we have to divide with respect to 8. So 275 is divided by 8. We are getting 34 with the remainder of 0. Again divide by 8. We are getting 4 with the remainder of 2. So here also we are taken from bottom to top, that is 423 is the result for this whole part. Next one is a 0.4, which will be a floating point. This will be multiplied with respect to 8. So we are getting 3.2. This 3 can be taken outside. So the point 2 will be here. This will be multiplied by 8. So we are getting 1.6. This 1 can be taken outside. So the 0.6 will be here, which will be multiplied with 8. We are getting 4.8. This 4 can be taken outside. So we are getting 0.8, which will be multiplied with 8. We are getting 6.4. This 6 can be taken outside. For the floating point, we can take the value from top to bottom. So until 3 digit, we can stop this conversion. So we stop here. So consolidate these two, we are getting 423.3146 is the result for this decimal number. So the next conversion is a decimal to hexadecimal number. So for the decimal number, the radix value is 10, and for the hexadecimal, the radix value is 16. So we have to convert the decimal number into hexadecimal. We need to divide with respect to 16 for the whole number. So 479 is the whole number. So we have to perform the division with respect to 16. So 479 we have to divide by 16. We are getting 29 with the remainder of 15. Again divide by 16. We are getting 1 with the remainder of 13. So for the hexadecimal, we are not using these numbers 13 and 15. We have to convert, that is in the equivalent value. For the 13 we have to use as a D, and for the 15 we have used the equivalent value as 15 we have to use the equivalent value as F. So for the 479 we are getting the hexadecimal result as 1DF. This will be the hexadecimal value. And for the floating point, they are given 64.20. This whole part, which will be divided with respect to 16, that is 64 divided by 16, we are getting 4 with the remainder of 0. So here also we take the result from bottom to top, that is 40. For the 64, we are getting the hexadecimal value as the 40. And for the floating point, that is 0.20, which will be converted into 16. So we are getting 3.20. This 3 can be taken outside. The 0.20 will be here, which will be multiplied with 16, that is 3.20. This 3 can be taken outside, and again we are getting 0.20, which will be multiplied by 16. So we are getting 3.20. So the 3 can be taken outside. For the floating result, we are take from top to bottom, that is 0.33. So consolidate these two values. So we are getting 40.333. This will be the hexadecimal equivalent value for this decimal number. So for the whole number, we have to divide with respect to radix of the particular number, and for the floating part of the value, we have to multiply with the radix of the particular number system. So in this way, we can convert the decimal number to any other number system. In next video, we have to see any other number system to decimal number.